Graphing rational functions. So, I don't know. Hopefully I fixed it. We shouldn't have any more issues as we go through. I don't know what I did, but here we go. This, you're going to write these down. Or at the top of your notes. You don't look at them. Just like, oh, they're written there already. And then you ask, well, what do I do next? Well, I decided this time you're going to write the steps yourself. Okay. So, follow along, either write them at the top, across, however you want to do it. But these are going to be the steps that we follow as we find our graph. Okay, so step 1 to graphing rational functions. First thing you're going to do is find the horizontal / oblique asymptote. Oblique asymptote is also known as a slant asymptote. Okay, step 2 is you're going to factor your numerator and denominator. So step 2 is to factor the numerator and denominator. Step 3 is to find wholes and vertical asymptotes. Your wholes are common factors. Your vertical asymptotes come from your denominator. Okay. Step 4 is to sketch your asymptotes. You're going to sketch out your vertical and horizontal asymptotes or slant asymptote. Step 5 is to find points to the left and right of the asymptote, plot, and connect. Now, for the points, it is user's choice. What points you choose to plug in and evaluate are 100% up to you. I just strongly suggest use small numbers. Hey, Mr. Red Card, can you shh? Thanks. All right, last thing we're gonna do is find the domain and range. All right, so these are the steps that we're gonna follow for the next problem. Huh? Who, me? That's why I paused and said, are we ready? I would just said, okay. I thought that I held on. I even printed a paper while holding. I want the world to see my struggle. All right, here we go. So we're going to follow these steps. So here our first problem we have is f of x equals 2x squared minus 7x plus 3 divided by x squared. Okay. Step 1, horizontal or slant asymptote. Okay. To identify whether it has a horizontal or slant asymptote or no asymptote in that sense from those two options, you're going to acknowledge the degrees of your numerator and your denominator. Okay. The degree of my numerator is 2. The degree of my denominator is 2. The degree of the numerator equals the degree of the denominator. Okay. Because of that, that means I know I have a horizontal asymptote. Okay. Because the degree of my numerator equals the degree of my denominator, I have a horizontal asymptote. That horizontal asymptote comes from my leading coefficient. Can someone tell me what are my leading coefficients? What's 2 and 1. My leading coefficients are 2 and 1. So therefore, my horizontal asymptote is at 2 over 1. I didn't have 1 there. So my horizontal asymptote is at y equals 2 over 1, which is just 2. And again, that's because the degree of my numerator equals the degree of my denominator. All right, what's step 2 tell us to do? Factor our numerator and denominator. We're going to start with the denominator because it's easier to factor first. What multiplies to give me -6, but adds to give me 1? What two numbers? 3 and -2. So therefore, my factors are x plus 3 and x minus 2. Okay, for the numerator, I'm going to quickly do the box. If I'm going to do, I like to call it an express box. It's a lot of talking to myself. And the first box, I'll put the first term, which is 2x squared. And the last box, I'll put the last term, which is 3. So I'm looking for what multiplies to give me 6, but adds to give me -7. So what two numbers multiply to give me 6, but add to give me -7? -6 and -1. So my other boxes would be -6 and -1x. Once the box is filled, what are you doing around the box? Greatest common factor. Around the box, you're going to find the greatest common factor. So what is the greatest common factor of 2x squared and -1x? Positive x. Okay. What is the greatest common factor between -6x and 3? I mean, -3. If the outside box is negative, then your factor is negative. That is your hint. Okay. What is the greatest common factor between 2x squared and -6x? 2x. What is the greatest common factor between -1x and 3? -1. So therefore, my factors of my numerator are 2x minus 1 and x minus 3. So now I have factored the numerator and denominator. I'm going to check and see if there are any holes. If there's a hole, that means they have a common factor. Is there a common factor? I have a +3 and a -3. They're not common. So therefore, there are no common factors. So there are no holes. No holes. Okay. Next, I want to change the color, but this bar won't go away, so I can't change my pen color, and it's driving me insane. So next, we're going to look at our vertical asymptote. Your vertical asymptote comes from setting your denominator equal to 0. So if I was to set each value of my denominator equal to 0, which is what you also should have done during your do now, right? In order to find your domain of your do now, you should have factored and set your denominator equal to 0. Okay, so x plus 3 equal to 0. That means that x has to be what? -3. X minus 2 equal to 0 means that x has to be +2. So those are my vertical asymptotes. Okay, next we're going to find our x-intercept. To find your x-intercept, this means you're setting your numerator equal to 0. Yep. To find your x-intercept, you're setting your numerator equal to 0. So if I set my numerator equal to 0, that's 2x minus 1 equals 0. And that's x minus 3 equals 0. So where are my x-intercepts? At 3 and 1/2. So 3, 0 and 1/2, 0. Okay, remember x-intercepts are x, 0, and y-intercepts are 0, y. So to find your y-intercept, that means you're going to make every x equal to 0. And it's best to go back to the original, in my opinion. So if you go back to the original and you make every x equal to 0, this goes away, this goes away, this goes away, this goes away. And what are you left with? I'm left with, in the numerator, I'm left with 3. In the denominator, I'm left with -6. So 3 over -6 is what I'm left with. So where's my y-intercept? 0, -1/2. Okay, do you see why it's easier to go back to the original instead of plugging it into the fraction? I mean, the factors. I mean, you could if you want to. I wouldn't stop you. But to me, it just makes more sense to go back to the original. All right, now you have every tool that you need in order to graph. So the first thing you're gonna do is graph your asymptote. So I have a vertical asymptote at -3. I'm gonna call this -3. Notice I gave you unnumbered graphs so that you can kind of put it in there. I have a vertical asymptote at 2. I'm gonna call this 2. Okay, I have a horizontal asymptote at 2. So I'm gonna put in okay. Next, I graph my asymptotes, and I'm going to graph my intercepts. So I have intercepts at, where are my intercepts at? There we go. So I'm going to be here at 3. We're going to call this 3. We have another x-intercept at, we're going to call this little guy 1/2. And I have a y-intercept at -1/2. All right, so we have to figure out where everything's going. So notice this is the easy part. This is freehand sketch. As long as you have values, you're good to go. When it says a test point, well, this one already has a point. That means that I know that my my function has to go through 3. And then it just approaches that asymptote. So it's going to continue. The middle is a special example of when your horizontal asymptote can be broken. I need to create a function where I can go through these 2 points. And if I'm not sure which way I'm going or how I'm going, I can choose additional points. So let's say I plugged in 2, -2. If I plug -2 in and see how it's going to behave, it's going to be a negative number. So I know all the values from 1/2 and below are negative numbers, which means that it's doing something like this. And I still need to approach this asymptote. This is an example of when your horizontal asymptote is broken. On the side of -3, we got to choose a value to plug in. I'm going to choose -4. Could you plug in anything you want? Yes, but why would you want a larger number than -4? I don't know. I won't stop you if that's what your heart tells you. You just have to figure out, is it above or below your asymptote? Figure out. So when we substitute -4 into here, what do we get? 2 times -4 is -8 minus 1 is -9. -4 minus 3 is -7. -4 plus 3 is, and -4 minus 2 is. So we end up in the positives, right? At 63 divided by 6, 10 something. So it would be in the top. So that means that our function is going to be above the asymptote instead of below the asymptote. And that is how you graph a rational function. You have to find all the little pieces and put them together. So therefore, your domain is all real numbers, but x cannot equal. What can x not equal? -3, or x cannot equal 2. Graphing rational functions is not for the faint of heart. It does take practice, which is why we have a bunch of different examples. And there are infinite possibilities of how your graph can look. Okay? So you can't learn it while taking a nap in class while your teacher is teaching. It's not going to go very well. So it's going to be a horrible test grade and quiz grade. All right. Tell your friend that when they wake up. No. I did not say those words. I initially started off with like a pretty expansive one, just to kind of for you to see how it can become a lot. Let's bring it down a notch and see what happens. Okay. So here we have f of x equals 3x divided by x squared plus 2. Okay. So the first thing we're going to do here is factor. Oh my gosh, not factor, my what's the face? What do you call it? My, yeah, that thingy. I had a brain fart. Oh my gosh. Horizontal asymptote and oblique. Thank you. Fill in the blank for me, guys. Comparing my numerator, my denominator. So the degree of my numerator is less than the degree of my, that's the wrong way. And I can't erase because my board won't let me. Is less than the degree of my denominator, which means that it is a horizontal asymptote. And hopefully from our pattern recognition, our pattern from the tables, we don't have to do anything except understand that it's going to be y equals 0. Now, if you do not, then you can, if you cannot see that, then you can go forth and do the whole shebang of dividing. But is it necessary to divide? No. If the degree of the numerator is less than the degree of the denominator, you have a horizontal asymptote at y equals 0. And that's it. Okay, so HA is done. Vertical asymptote. Is there one? If I was to set my denominator equal to 0, would that be possible? Is that possible? No, there's nothing that I can plug in that's going to make this equal to 0. So is there a vertical asymptote? No, sorry, Bob, there isn't. In case you were wondering. All right, so next, x-intercept. How do I find the x-intercept? We take our numerator and set it equal to 0. What is that? 0. I was like, I'm waiting. I was like, someone's gonna tell me? No. Why'd you ask? You gotta keep it alive. You're right. All right. And y-intercept. If I'm at the origin, what's my y-intercept? 0. Because you only can have one y-intercept. So if your x-intercept is at the origin, guess where your y-intercept is? 0 at the origin. This is an example of when your horizontal asymptote can be crossed. Your horizontal asymptote is not as a hard line as your vertical. There are points at time when the horizontal will be crossed. Oh, my bad. Like, I don't know. Horizontal can be crossed, is what I was trying to tell you. Like, no. Horizontal can be crossed. Vertical is just cannot be touched. Okay. All right, here we go. Origin. So we just got to figure out. We have our asymptote. Asymptote is only affected around the origin, but not at the origin. And we just got to figure out what's happening on the other sides. So, I would choose 1. Would you choose any numbers higher than 1 and -1? No, I wouldn't personally, but if that's what your heart tells you to do, f of 1, that puts me at 3/3, which is what? 1. So then it's going to do this. It's going to go to 1. I know that for a fact. All right, f of -1, what is it going to do? It's going to go to -1. So it's somewhere down here. Okay. The thing is that it has to somehow come back down to the asymptote. So at some point, your graph has to do this and then head towards the asymptote. Again, at some point, your graph is doing this, but then it has to come back down and head towards the asymptote. Because that's where it's trying to get. It tried to get away, but it's like, no, this is where I want to be. I know. Story of a lot of people's relationships, huh? I don't know. I didn't know you're trying to escape me. So your domain here is, the graph is going to go forever to the left and forever to the right. So therefore, all real numbers. Okay. So compared to our first one, this one's way easier. Okay. I did the first one a little harder so that we can go through all the